this video, and it'll be much shorter because there's only these 4 examples, is to look at an image and create a sine and a cosine function for each. And so usually, like, there's a predominant, like, one is, it seems like it's in its home position, so to speak. So like when I see the first graph, I see it starting at 0, 0. To me, that looks like a sine wave. So my first thought would be, okay, it's going to be y equals, and there's a amplitude of 2. So I say 2 sine, and then if I notice that 8 is my frequency, sorry, of my wavelength, I can go back to this idea of 2 pi over b, and just do again, like this is like the beauty of the relationship between a frequency and wavelength as they're inverses, is that just do 2 pi over 8 to get what the frequency is. Oh, pi fourths. So then I know my coefficient is pi fourths x. And so, so like, and there's no pushing up, pushing down. So like, that's it. That's my sine wave. Okay. Now, cosine, remember, cosine normally starts here. So if I want to make this a cosine graph, or sorry, cosine equation, starting at the top, and just so you know, it's still going to have the same frequency. So pi fourths x. I'm going to have to shift my cosine. So cosine normally starts up here, and I want it actually to start to the right by a quadrant value, or by 2. So I'm going to shift that to the right 2 units. Now, sometimes students accidentally try to take the current graph and push it back to the start of a cosine. Don't do that. Don't make this graph into a cosine graph. Choose a cosine equation to get this graph. Now, some of you may have saw this from a negative cosine's perspective, and that's awesome. Negative cosine starts here, and then you would have shifted it to the left by 2 units. So you could also have said y equals negative 2 cosine, still the same frequency, pi fourths, and call that x plus 2. I would totally accept that. Okay, let's look at the next one. To me, it looks like it's in cosine's home position because it's starting at the top. Amplitude of 3. So I'm going to say y equals 3 cosine. And then it looks like I have more than one period, which is fine. It goes all the way out to pi. That's the first time it repeats itself. So remember, it's 2 pi over b. So 2 pi over pi, which means my frequency is 2. So 3 cosine of 2x. Done. Now, let's make it into a sine wave. So I'm going to still keep the same amplitude of 3. It's still going to have the same frequency of 2. But remember, sine starts here. So here's my sine wave. So it looks like I'm going to have to move a sine wave back, move it to the left by this quadrant value of pi fourths. So moving it to the left by pi fourths. Now, if you saw it as a negative sine wave, which maybe you did, then you would have moved that to the right by pi fourths. So you could also have said, or y equals negative 3. Oh, I just realized thank you for shouting at me in the video. That's not cosine, that's sine. So call that sine. Okay. Or you could say negative 3 sine of still a frequency of 2 x minus pi fourths. Because starting from the negative, you're shifting to the right, pi fourths. That's a minus. Okay, let's look at the next one. 2 more to go. So this one, I can tell my equilibrium has been changed. My equilibrium is pushed up 2 units. So I know that's going to be affecting like what I add to the end. So, to me, it looks like a negative cosine graph, right? Because we're 2 below. So I'm going to start with y equals negative 2 cosine. There'll be some frequency of x, and then plus 2 because I'm shifting up everything 2 units. And then again, remember, amplitude is how much you deviate from the line of origin, or that central point. Okay, so what is our period? It looks like it's 12 pi is the period. So we do 2 pi over b, so 2 pi over 12 pi, which means I have a frequency of 1/6. So I put 1/6 there, okay? And, if you see this as a sine function, remember sine starts there, and sine wave would have been shifted to the right by 3 pi. So I could say y equals 2 sine of, it's still going to be 1/6, and it'll be x minus 3 pi plus 2. So again, your sine wave starts here, and so I just need to push that to the right, 3 pi. Maybe you saw it as a negative sine wave. Again, you don't always have to do this, but if you saw it as a negative sine wave that shifted to the left by 3 pi, then you could have written it as y equals negative 2 sine of 1/6 x plus 3 pi. Don't forget plus 2. Okay, last one. It looks like our equilibrium is here. Draw the halfway point. So it looks like our equilibrium is down 2 units, and our amplitude is 3. Right, 3 is how much we deviate from that line of that amplitude, and it's starting at that origin. So to me, this looks like a sine wave. So I'm going to call this y equals 3 sine of some frequency of x minus 2, because I'm down below 2. And it looks like 4 is a fundamental wavelength. So we do 2 pi divide by 4. So my frequency is pi over 2. Okay. And then, again, let's adjust to a cosine wave. So remember, cosine would have started up here. So had this been cosine, looks like we need to move it to the right by like one value. So I could say y equals 3 cosine. Frequency is still pi over 2, but we're shifting it to the right 1 unit, and then minus 2. Maybe you saw it as a negative cosine. Might as well complete it, right? Negative cosine would have started here, and that would have been shifted to the left by a unit of 1. So negative cosine could have been negative 3. There's our cosine function, pi over 2, x plus 1, and then minus 2. So since every sine wave is a cosine wave and every cosine wave is really a sine wave, like try to find what you think is like the home like function, and then you just that's like the main one, and then you phase shift the other one. So all right, as promised, much shorter. Very good.